Okay, let's understand the basics, the very, very basics of databases in a very quick video before we go and learn about SQL, which is very, very interesting topic. But before we go to SQL, I'll give you a brief overview of what databases are. Remember, databases is a full-fledged subject at undergraduate and graduate level computer science. So I'll not be able to cover everything here, but I'll cover the basics that we need so as to understand SQL better, right? So databases, you might have heard of databases like, you might have heard these names like an Oracle database or a MySQL database, right? Or a Microsoft SQL server, right? These all are popular databases. These all are very popular databases, and all these are often referred to as relational databases. They're often they're often referred to as relational databases. That obviously raises the question: are there something called non-relational databases? Yes, there are something called as non-relational databases that have become more popular more recently. That have become more popular more recently. Traditionally, since the 1970s and 60s, relational databases are the most widely used databases. And we will limit this discussion only to relational databases. But whatever we learn about SQL, right, some of the concepts that we learn are also useful if you are using a non-relational database. For example, there are non-relational databases like MongoDB, right? Which is a very interesting database structure, which doesn't follow some of the concepts of a relational database. I'll not go deep into what a relational database is, what a non-relational database is, what are the differences. I'll not go into it right now because our focus is about learning SQL. Some of the lessons that we learn about SQL, even though SQL was designed for relational databases, the non-relational database community also has adopted SQL or variations of SQL for processing data or for obtaining data, right? So the big question here is, why databases? Why use a database? Now, before we go into this question, what are the alternatives? Let's understand what is an alternative that we have. Instead of storing your data in a database, why don't I just store my data in a text file? In a text file, like a CSV file, right? These are called flat text files, or these are called as flat files, because you literally store your data in a flat structure, right? You basically, if this is your file, you save column your variable 1 or column 1, column 2, column 3, column 4, so on and so forth, right? You just store it in a flat fashion because this is like a flat display of data, right? This is that's the alternative that we have. So why don't we store our data in a flat text file like a CSV? Why do we use a database? Why can't we just use a flat file? Now, databases typically databases provide us lots of nice software. So databases, in a nutshell, are mostly software that help us achieve lot of things that simple flat text files can't. For example, a database gives us a lot of very interesting tools. It makes our life simpler, easier, right? A lot of times faster, reliable, and also secure sometimes, right? It makes access to data. Suppose if I have data sitting here, databases make access to the data far simpler and easier through a standard interface called as SQL, which we'll learn later. It will also make it much faster. For example, imagine if I have a text file where I want to determine all the values. For example, I have column 2. Let's say I have column 2, right, in this CSV file. This is my CSV file, right? I want to take all the values. Let me take an example here, right, so that you'll better understand it. Suppose I want to get all the rows. Let's assume all these are the rows. This is row 1, row 2, row 3, row 4, so on and so forth. Suppose I want to obtain all the rows of data. All the rows of data where column 2 is greater than 100. Let's assume I want to do that. How do we do it in a text file? We load this whole text file. We load this whole text file using any programming language, C, C++, Java or Python, right? We load this text file using file handling tools. Then we go through each of these rows to see if the value here is greater than 100 or not. And that's very time consuming. A database uses some very interesting software tricks called as indexing to make this type of retrieval of data way faster, right? Also, to retrieve this data, you need to be a good programmer because you need to first load the data in C, C++, Java or Python. And you need to explain how to actually obtain these rows. You have to write code saying that, okay, first load this data, then go row by row. When you go row by row, check if each of these values is greater than 100 or not. If it is, then return, or else don't return. So you have to have knowledge of lots of programming. You have to be able to explain how to retrieve this data, right? Which many people may not have. So a database provides a very simple and easy to use language called as SQL, which we'll learn later in this chapter, with which you just have to say, okay, all you have to say is, literally, this is what you have to say. You have to say, I want all the rows where this column value is greater than 100 without worrying about anything else. The database takes care of retrieving the data for you. You don't have to know about file handling. You don't have to know advanced programming. You don't have to worry about if this table is very large. You don't have to know concepts in operating systems, etc. All you have to do is write a single line, literally a single line of SQL query. Everything is taken care for you, right? So database consists of lots of interesting software to make your life simpler, easier. Also, obtaining this data is way faster because databases do a lot of advanced build a lot of advanced data structures called indexing data structures, which make it extremely fast to retrieve this data. It's also reliable and secure because imagine if your hard disk crashes, your whole data is gone for a toss. Databases back up your data at multiple places to ensure that your data can be accessed reliably and securely, even if there are hardware crashes, even if your hard disk typically crashes. And databases typically achieve that using a wide spectrum of techniques. A very simple technique is, suppose you have 3 hard disks. And by the way, databases are hosted where you have a lot of data storage. Okay, if this table is stored here, a copy of it is also stored here and another copy is stored here. This is called triplicate storage. Now, if this hard disk fails, that's okay. We have 2 other hard disks where the data is readily available, right? So database as a software takes care of all of this internally for you so that you don't have to worry. That's one of the biggest advantages of using databases over simple flat files, right? Simply speaking, it makes obtaining data that we want way simpler, way easier, way faster, way more reliable and secure, right? That's the reason why we use databases over simple flat text files. Okay, having learned this basics of why we need a database, right? And the fact that relational databases are extremely popular. Remember, some of these companies like Oracle make most of their money through databases, and they're multi-billion-dollar companies. A lot of interesting startups like MongoDB have become billion-dollar startups by leveraging new advances called non-relational databases. So databases, whatever you do, whether you're booking a flight ticket, whether you're booking a flight ticket or a train ticket, whether you're booking a movie, right? Whether you're booking a movie ticket, all of them, or even you're accessing this website, right? All of that happens through a database. We use a MySQL database ourselves at the back end of this website, right? So databases are probably the most used piece of software that we don't know about. We know about Microsoft operating systems, we know about Android operating systems, but databases are that piece of software which most of us don't know, but which runs our life. Literally speaking, all of your Android phones, your Android iPhones, All of them actually have a database internally to store your contacts information, right? That has to be stored somewhere, right? There is actually a database sitting in each of your Android phones and iPhones. That's how powerful databases are, right? So now let's go into a simple concept called tables. So in a relational database, all of our data is stored across multiple tables. Okay, let's take a simple example to understand why we are storing the data in tables. Tables is very simple. We all understand what a table is, right? Suppose if I have a flat text file, right? Like a comma separated value file, right? We know that, okay, this is actually like a tabular structure. If I'm storing my data in a CSV file or a comma separated value file, what am I doing? I'm storing some data with comma separation. This is value 1, value 2, value 3, value 4, so on and so forth. This you can think of logically as a table, right? Each of them has columns and then you have rows here. So tables are anyway fundamental to all of data storage that we do today, whether it's a flat file or a relational database. But there is a very interesting difference here. Imagine, let's take an example, and we'll use this example multiple times across this chapter. But let's take a very simple example here. Let's assume I have some data about movies. Okay, so let's assume for each movie I have a movie ID, right? I have a movie name, right? Let's assume I have a movie name. I have the year in which this movie was released. I have for each actor, let's assume I have an ID for the actor. I have the actor name, right? And the gender of the actor. Now look at this. When I want to store some data, let's assume movie ID is, let's say 1. Movie name is, let's say, Pirates of the Caribbean. Pirates of the Caribbean. I don't remember the year it was launched. Let's assume the year is some 2008. Let's say actor 1. So the Pirates of the Caribbean movie have multiple actors, right? The actor ID, let's assume, is, let's say, 101. The actor name is, I don't remember the actors also. I remember the character names. Some name, okay, some name. Name 1. Gender is, let's say, male. Now, since there are many actors in this movie, right, I'll have to repeat the same data. Pirates of the Caribbean 2008. Now, suppose there is a second actor. Again, name 2. Let's assume this is also a male character. Now, if I have 10 actors, in the movie, I'm literally repeating the data 10 times. If you look at this data that I have will be repeated 10 times. Of course, the actor ID, everything will change. The actor ID will change. Name 3, let's say female, 104. Name 4, some female, so on and so forth. While this part of the information changes for these 10 rows, right? For these 10 rows, the actor details will change. But the movie details, we are simply copying the same thing. Just imagine how much space we are wasting by just duplicating. This is all duplication of data. So instead of storing all of this in one table, what if I store this in multiple tables? That's a very key idea of relational databases, right? And this idea is called normalization. And this normalization is a concept of normalization in databases. And this is a very wide subject which I'll not go into in detail. I mean, I can spend 10 hours just explaining about database normalization, right? I'll not go into it. But the core idea is this. Given this simple example, there is a lot of duplication of data, right? Now, to avoid this duplication, relational databases come up with a very simple scheme. It says, let's create multiple tables. Instead of storing everything in one table, T, let's assume this table is T. Let's break it up into multiple tables. Let's say T1 will contain the movie ID, the movie name, and the year of release. This is T1. right? Let's assume T2, movie 2, table 2 contains actor ID, actor name, and actor gender. Now table 3 will contain movie ID and actor ID. I've broken this up into 3 tables, wherein, now remember, now look at this, right? For each movie here in this table, let's look at this table, right? Let's look at this table, right? These are the columns of the table, right? Now let's look at this table. For each movie, only one row will be present in this table. In this table, only one row will be present. So we are no more going to duplicate this data. And each movie name can be uniquely identified. See, each of these rows, right, can be uniquely identified using this movie ID, right, in this table. Now my second table is my actor ID. It contains only 3 fields: actor ID, actor name, and gender. Now here also, for every actor, there will only be one row, and each actor can be uniquely identified, again using my actor ID, because 2 actors can have the same name. 2 movies can have the same name. Multiple movies can be released in the same year. Of course, there are many people with the same gender. So the unique way to identify each of these rows in the table can be done using movie ID. Similarly, in this table, each row will have a unique actor, and each actor will have a unique actor ID. Right? Now let's come to the third table. Now in the third table, I will store for each movie and for each actor. Suppose if I have movie ID 1. So let's take this example only, right? I'll store 1, 101 here. I'll store 1 and 101. I'll store 1, 102. Because actor 101, 102, 103, 104, all of them acted in movie ID 1, right? Here, neither movie ID 1 nor actor ID 1 will uniquely define a row, but the combination of both of them will define uniquely every row, right? You will not find 1, 101 and again 1, 101. This is of no use. This is not giving us any additional information. But both these rows together can uniquely identify each of the rows here, right? So now I'll explain what these concepts are. There is a reason why I'm highlighting all of them in green. Because movie ID uniquely determines each of the rows here, movie ID is called the primary key. It is called the primary key in databases. Similarly, actor ID is referred to as a primary key. Now, actor ID is called the primary key of table 2. The primary key of table 3 is a combination of both these columns, right? So both these columns together constitute the primary key of this table, right? So we have 3 tables. The first table has movie ID as the primary key because each row can be uniquely identified using the primary key. The second table, the first table is basically the movie table. The second table is the actor table. The third table is the casting table, where we are saying which actor was casted in which movie, right? So these are my unique keys. But there is also another concept called as foreign key. A foreign key basically means that whatever, so here these two are foreign keys. A foreign key basically means that whatever values that I have here should also be present here, right? If you have a movie ID here which is not present in the movie table, that is wrong information. So movie ID in table 3 is a foreign key with respect to table 1 because this movie ID should be present here, otherwise it's not useful. Similarly, actor ID here is a foreign key to the actor ID column in my actor table, right? So these two concepts are very important. The first one is called a primary key. The second one is called a foreign key. A primary key uniquely identifies each of the rows in a table. A foreign key tells us what all values can be present in a column of data. Right? Very interesting concepts. We will use all of this. Again, remember, I have covered a semester long subject in a very short duration here to give you an overview of a few concepts so that we can understand SQL better. So we have understood what are the databases, what are the popular databases here, where do we use these databases on a day-to-day basis, why we are using a database in the first place, why not just store the data in a simple text file, and most importantly, why are tables very important? Why is breaking up data or normalization across multiple tables very important in databases? And we have shown how to break this data into multiple smaller tables so that we are not duplicating data, thereby saving space. Okay, given this background, now we are much more well equipped to go into some concepts of SQL and database.